Let's draw a graph of a temperature regulating animal. Metabolic rate as a function of environmental temperature. Now, when we draw these graphs, the animal is always at rest. It can't even have recently eaten, because then it would be spending energy to digest that food. It's got to be an animal awake, because when you're not awake, you allow your body temperature to go down a little bit and you have a lower metabolic rate. So this is an awake animal at rest. On the y-axis is metabolic rate, and that's typically presented in metabolic rate units, MRUs. On the x-axis is the temperature of the environment. Now it turns out there are a set of temperatures at which an endotherm at rest is going to be different for every animal. This includes us, of course. Any animal that regulates its body temperature will have a set of environmental temperatures within which it doesn't have to spend any energy to regulate its body temperature. That range of temperatures is known as the thermoneutral range. The minimum value of the thermoneutral range is known as the lower critical temperature. The upper value is known as the upper critical temperature. Now, when it's cold out, you have to spend energy to stay warm. Okay? So when the temperature outside, when the temperature in the environment of this animal falls below the thermoneutral range, there are incurred heating costs. So the metabolic rate has to go up to supply the calories, supply the amount of energy being spent by this animal to stay warm. When this animal is at temperatures above its thermoneutral range, it has to spend some calories to stay cool. Okay, this is the heating cost, this is the cooling cost, this is the thermoneutral range. Now, animals are always spending energy. Life isn't free. Always spending energy, just maintaining bodily functions, and that's known as the basal metabolic rate. That's the least energy you can spend. So here's an animal not doing anything, at rest, within this range, not spending any energy to maintain its body temperature, but still quite a bit of energy is being spent. Okay, below the thermoneutral range, here is the cost of heating. So you're spending more calories to stay warm. How do we quantify the cost of staying warm? Well, typically, what you're going to use for units are MRUs per degree. So how do you find that from this graph? Well, you take what your change in metabolic rate units is, and let's see, what is that? That's from 16 down to 10, so that's 6 metabolic rate units. 6 metabolic rate units is the cost for maintaining body temperature when the environmental temperature is 5 units below the thermoneutral range. So what have we got for our cost of heating? We have 6 metabolic rate units per 5 degrees, so 6/5 metabolic rate unit per degree temperature. Okay? The cost of staying cool seems to be approximately 2 metabolic rate units per degree, yeah? Okay. A last thing I'd like to show you at this point is that you can actually determine the body temperature of an animal by extrapolating how much it costs that animal to maintain its temperature below the thermoneutral range. So what I'm saying is if I take this line and I extrapolate it down to the x-axis, I'm going to find what the animal's body temperature set point is. This, 16 I guess, is the body temperature set point. Maximum amount of energy an organism can spend tends to be 10 times the minimal amount of energy that animal must spend. So the maximal metabolic rate, is usually 10x the basal metabolic rate. And that relationship of maximal metabolic rate to basal metabolic rate is known as the aerobic scope of the animal.